Next, NWCR method means northwest corner rule method. So under this method we used four steps to get initial basic feasible solution. So northwest corner rule method is most simple and efficient method to obtain initial basic feasible solution under transportation problems. So step number 1, start with the cell at the upper left corner, means northwest corner of the transportation matrix, and allocate as much as possible equal to the minimum of the rim value for the first row and first columns. So means we started allocation from the upper left corner, so northwest corner of the given transportation matrix, and allocated the minimum rim value given in the problem. So that is step number 1. And step 2, so under step 2 there are two cases. In first cases, if allocation made in step 1 is equal to supply, then we move vertically down to the cell. So in case what we made allocation in step 1 it's equal to supply, then we move vertically down to the cell, so that is second row first column. In case if allocation made in step 1 is equal to the demand, then we move horizontally to the cell. In case allocation made in step 1 is equal to demand, we move horizontally, that is first row second column. Next step 3, if a1 equal to b1, means if a supply equal to demand, then we move diagonally to the cell, that is second row and second column. In case supply equal to demand, then we move diagonally, that is second row and second column. Next step 4, the last step, continue the same procedure step by step till an allocation made in southeast corner cell of the transportation problems. So we continue the above procedure step above procedure step by step till we reach the southeast corner cell of the transportation table or transportation matrix. So we started a step 1 from allocation from upper left corner, and till we continue the same procedure to reach southeast corner of the transportation table. Here I write one example to solve. Example number 1, obtain the initial basic feasible solution of a transportation problem whose cost and rim requirement table is given below. So in this transportation matrix or transportation problem, there are 3 destinations and 4 sources or origins. So D1 or destination 1 demand is 7, destination 2 demand is 9, destination 3 demand is 18, and horizon or sources 1 supply is 5, origin 2 supply is 8, and origin 3 supply is 7, origin 4 supply is 14, and the total value of demand and supply is 34. And these 5, 8, 7, 14, 18, 9, 7 values are called the rim values, and 2, 7, 4, 3, 3, 1, 5, 4, 7, 1, 6, 2 are called the transportation cost. Here I solve the given problem by using NWCR method rules. First, I write the computation of initial basic feasible solution by using NWCR method. So before going to solve the problem, first we check the problem, means there exists a initial basic feasible solution or not to the given problems. So how to check ಅಂತ ಹೇಳಿದ್ರೆ, the sigma ai must be equal to sigma bj, means the supply must be equal to the demand. The total supply value is 34 and the total demand value is 34. So in this case there exists initial basic feasible solution. So then we move next step to solve the problem. The first step under NWCR method is start with the top or left corner, means northwest corner. So this is the northwest corner of the transportation matrix. We started allocation from this cell. So and we started top or left corner, we started the allocation from top or left corner and allocate as much as possible equal to the minimum of the rim values. So these are the rim values for first allocation, so first row and first column. So we allocated the minimum value. So 5 is the minimum value in the given matrix. 5 and 7, we compare both 5 and 7. 5 is the minimum value. So write 5 and subtract this amount or this value from this. 5 minus 5 0 and 7 minus 5 2. So in case the allocation is equal to the supply, then we move vertically down. So vertically down, next allocation is first column second row. So we allocated the minimum rim value 2 and 8. So under these two values, 2 is the minimum value, 2 minus 2 0 and 8 minus 2 we get 6. And if the allocation equal to demand, then we move horizontally. So this is the next allocation, and here 9 and 6. So under these two values, 6 is the minimum value, we allocate 6 here, and 6 minus 6 0, 9 minus 6 we get 3. If allocation equal to supply, then we move vertically down. 3 and 7 are the rim values. 3 is the minimum rim value. 3 minus 3 is 0. 7 minus 3 we get 4. If allocation equal to demand, then we move horizontally. 4 and 18 are the rim value for this allocated cell, and 4 is the minimum value. So here 18 minus 4 I get 14, and 4 minus 4 0. So if allocation equal to supply, then we move vertically down. 14 and 14. So the supply and demand both are satisfied. So we reach the final steps at the last step in NWCR method. We started the allocation from northwest corner and we reach to southeast corners. So then we write conclusion. The conclusion is the total transportation cost is given by, so here we write the allocated cell values. So in this matrix we allocated 6 cells, 1 2 3 4 5 and 6, and we also write like this: m plus n minus 1. So m means number of rows, n means number of columns, minus 1. So number of rows 1 2 3 4. So 4 rows and 1 2 3 columns, 4 rows 3 columns, 7 minus 1. So there are 6 independent non-negativity allocations. So ಈ ಪ್ರಾಬ್ಲಮ್ m plus n minus 1 ಏನಾದರೂ ಬಂದರೆ ಆ ಪ್ರಾಬ್ಲಮನ್ನು ನಾವು ನಾನ್ ಡಿಜೆನರೇಟ್ ಬೇಸಿಕ್ ಫೀಸಿಬಲ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇದನ್ನು ಮತ್ತೆ ಇಂಪ್ರೂವ್ ಮಾಡೋ ನೆಸೆಸಿಟಿ ಇರೋದಿಲ್ಲ. ಓಕೆ, ಸೊ ಈ ಒಂದು ಪ್ರಾಬ್ಲಮ್ಗೆ ಆಪ್ಟಿಮಾಲಿಟಿ ಚೆಕ್ ಆರ್ ಆಪ್ಟಿಮಾಲಿಟಿ ಟೆಸ್ಟ್ ಇರೋದಿಲ್ಲ. ಯಾಕಂತ ಹೇಳಿದರೆ ಅದು m+n-1ಗೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. ಅದನ್ನು ನಾವು ನಾನ್ ಡಿಜೆನರೇಟ್ ಬೇಸಿಕ್ ಫೀಸಿಬಲ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ದ ಟೋಟಲ್ ಟ್ರಾನ್ಸ್ಪೋರ್ಟೇಷನ್ ಕಾಸ್ಟ್ ಈಸ್ ಗಿವನ್ ಬೈ here we write the 6 allocated cells. So x11 equal to 5, x21 means second row, first column equal to 2 and x22 equal to 6, x32 equal to 3 and x33 equal to 4, x43 equal to 14. Therefore the total transportation cost is 5 into 2. So we multiplied the transportation cost and the rim values. We just multiply the transportation cost and rim values. 5 into 2 plus 2 into 3 plus 16 through 3 plus 3 into 4 plus 4 into 7 plus 14 into 2, 10 plus 6 plus 18 plus 12 plus 28 plus 28. So the total transportation cost is rupees 102. So this is the problem. So this is the solution for given problem.